Today, a line is described indirectly. We know another line it is parallel to, and we know it passes through the midpoint of a segment. Our goal is to combine those clues and locate one exact X-intercept.
Here is the exact source problem. Line L is parallel to 3x plus 5y equals 20 and passes through the midpoint of the segment joining -4, 9 and 8, 3. We need the x-coordinate of line L's x-intercept.
The choices are 12, 14, 10, and 36/5. Several are close enough to arise from a single misstep, so I should not estimate. I need a line equation that satisfies both given conditions.
Separate the clues before calculating. The two endpoints determine one midpoint. Parallelism determines the direction of the new line. A point and a direction then determine exactly one line, whose intercept we can evaluate.
I will begin with the midpoint formula. Average the two x-coordinates for the new x-coordinate and average the two y-coordinates for the new y-coordinate. Each coordinate must be divided by 2.
For the horizontal coordinate, -4 plus 8 is 4. Dividing that sum by 2 gives 2. The negative sign belongs to the first endpoint and must stay in the addition.
For the vertical coordinate, 9 plus 3 is 12, and 12 divided by 2 is 6. So the midpoint of the segment is the point 2, 6.
A quick geometric check supports that point. 2 lies halfway between -4 and 8 because it is 6 units from each. 6 lies halfway between 9 and 3 because it is 3 units from each.
Now I need a line parallel to 3x plus 5y equals 20. In standard form, keeping the same x and y coefficients preserves the same direction, while changing the constant shifts the line.
That family is parallel because every member has slope -3/5. Solving 3x plus 5y equals c for y gives -3/5 x plus c over 5.
The original constant 20 is not automatically retained. If I kept it, I would simply reproduce the original line, which does not pass through the midpoint because 3 times 2 plus 5 times 6 is 36, not 20.
Substitute the required point 2, 6 into the parallel family. 3 times 2 is 6, 5 times 6 is 30, and their sum is 36. Therefore, the new constant is 36.
So line L has equation 3x plus 5y equals 36. This equation now encodes both clues. Its coefficients give the parallel direction, and its constant makes the line pass through the midpoint.
An x-intercept is where the line crosses the x-axis. Every point on the x-axis has y-coordinate 0, so finding an x-intercept means set y equal to 0, not x equal to 0.
Setting y to 0 in line L leaves 3x equals 36. Dividing both sides by 3 gives x equals 12. The x-intercept point is 12, 0.
The problem asks for the x-coordinate, not the ordered pair, so the requested value is 12. That matches choice A. We have completed one exact standard form solution.
I want a second method that begins with slope rather than preserving standard form coefficients. From the original equation, 5y equals -3x plus 20, so the slope is -3/5.
A parallel line uses that same slope and passes through 2, 6. Point slope form therefore says y minus 6 equals -3/5 times the quantity x minus 2.
At the x-intercept, y is 0. Substituting 0 gives -6 equals -3/5 times x minus 2. This equation reaches the intercept without first expanding the whole line.
Multiply both sides by 5 to clear the denominator. We obtain negative 30 equals negative 3 times x minus 2. Divide by negative 3 to get 10 equals x minus 2, then add 2. The second method also gives x equals 12.
Now I will verify the midpoint condition directly. Substituting 2, 6 into 3x plus 5y gives 6 plus 30, which equals 36. The required midpoint lies on line L.
Next, verify parallelism. Both equations have the coefficient pair 3 and 5, so both have slope negative 3/5. Their constants differ, which makes them distinct parallel lines rather than the same line.
Finally, verify the intercept. Substituting 12, 0 into line L gives 36 plus 0 equals 36. Therefore, 12, 0 is on the line and on the x-axis.
Choice B, 14, can result from a midpoint mistake. If someone adds negative 4 and 8 but forgets to divide by 2, they use 4 instead of 2. Pairing 4 with 6 produces constant 42 and false intercept 14.
Choice C, 10, appears naturally in the second method when 10 equals x minus 2. Stopping there ignores the horizontal shift inside the parentheses. We must still add 2 to obtain 12.
Choice D, 36/5, comes from dividing the constant by the y coefficient. That sets x equal to 0 and finds the y-intercept. For an x-intercept, set y equal to 0 and divide 36 by the x coefficient 3.
There is one more common trap not listed among the choices, keeping the original constant 20. Parallel lines share direction, not necessarily every term of one equation. The midpoint test immediately rejects the original line.
Let us transfer the strategy. A new line is parallel to 2x minus 3y equals 7 and passes through the midpoint of the segment with endpoints 1, 5 and 7, 1. Find its x-intercept.
First, I average the endpoints. The x-coordinate is 1 plus 7 over 2, which is 4. The y-coordinate is 5 plus 1 over 2, which is 3. The practice midpoint is 4, 3.
Keep the coefficient pair 2 and negative 3, and write the parallel family 2x minus 3y equals k, substituting 4, 3 gives 8 minus 9, so k equals negative 1.
The practice line is 2x minus 3y equals negative 1. At its x-intercept, y is 0, so 2x equals negative 1 and x equals negative 1/2.
For an x-intercept, set y to 0. For a y-intercept, set x to 0. Naming the axis condition before calculating prevents the exact confusion represented by choice D.
My 4-step plan is: average corresponding endpoint coordinates, retain a proportional coefficient pair for the parallel direction, substitute the midpoint to determine the new constant, and set y equal to 0 for the x-intercept.
Returning to the source problem, the midpoint is 2, 6. Substitution into 3x plus 5y equals c gives c equals 36. So line L is 3x plus 5y equals 36.
At the x-intercept, y equals 0, leaving 3x equals 36. The exact source answer is choice A, 12.
For this workbook question, that chain leads unambiguously from the endpoints to the midpoint, from the midpoint to the parallel equation, and from the equation to the final x-coordinate 12.
Optional SAT math study resources are linked in the description. If you purchase through an affiliate link, the channel may earn a small commission at no extra cost to you. As an Amazon associate, I earn from qualifying purchases.